Good evening again. I just thought I'd digress a little bit because a lot of my students having problems when you're doing factorising a trinomial. For example, x cubed plus 2x squared minus 5x minus 6 equals 0. Now we know with a binomial, quite easy, you can use your quadratic equation, you can use a cross method, you can use, for non-monics, all these fancy little ways to do it, which I will show you my little tricks to them. When you're doing a cubic, we're using, like the null theory, the null factor theorem, we find a value for x that fits the equation. And they don't give it to you too hard. You sort of try, with trial and error, x is equal to 1. So we test it, 1 cubed plus 2 times 1 squared. A little hint, always put in the value of x in brackets. Makes a big difference if it's negative, because negative 1 squared is very different to negative 1 squared. It does not equal, and you will get it wrong. Negative 1 squared is negative 1 times 1 squared, which is just negative 1. But negative 1 all squared is you're timesing all of that by itself, which is positive 1. So be very wary. One of my rules is when you're doing substitution to put in them in brackets so you don't make a mistake. So let's go back to this one. That's minus 5 times 1 minus 6 equals 0. Now this would be a good non-calculator one. So it's 1 plus 2 is 3, minus 5 is minus 2, minus 6 does not equal, so it doesn't work. So we can cross out that one. Then we try x equals minus 1. And because you've got a few pluses and minuses, and that there will also make that a minus, let's have a look. It's 1 plus 2 is 3. Minus 2 minus 6. Let's try minus 1. So I get minus 1 cubed. I hope I wrote that down wrong. Right? Yes, it is. Minus 1 cubed plus 2 times minus 1 squared minus 5 times minus 1 minus 6 equals 0. When you're cubing or an odd power of a negative root, it's just a negative. Squaring or an even power is a positive. A negative times a negative is a positive, and a negative. So we get what minus 1 plus 2 is 1, plus 5 is 6, minus 6 is 0. And bingo. So I know that x equals minus 1 is a solution. Now this is where it comes in nicely, because now we can say that x equals minus 1 is a solution. Now, like we do when we do our x minus 1 bracket x plus 1 equals 0, we bring this to that side. Before we used to take it to the other side to find the solution. That just means that x plus 1 equals 0 is one of the factors. So x equals minus 1 is a factor, it becomes x plus 1 is a factor. So x plus 1 times something will equal 0. So how do we do this? If we know it's a factor, we do long division. Now I have a very special way of doing long division. I'm going to explain it to you in simple terms, and then we're going to equate it with doing it with cubics. My way of teaching long division is this, and if you follow this for doing it with algebra, it makes it much easier. My rule is there's a little times here. How many 12s go into 2? It doesn't, so 27. Now my rule is, when I'm teaching it to my junior students, is I have to write down on the side what they are doing. So it's 12 times what is close to 27, as you know that will be 2, which is 24. And what we do normally is that goes here, whoops, the 2 goes up the top, and we put the 24 underneath, and we minus it, and we get 3. Then we bring down, and we go, okay, how many 12s in 33? We go, 12 times 2 still, because 3 is 36. So you put the 2 up the top on top of that one, and we bring 24 down, and we minus. And we go, no, whoops, that, take that away. 13 is 9. And then I go, 12 doesn't go into 9, which is good. 96. 12 times 8 is 96. And so I put the 8 at the top, the 96 down the bottom. That was a good guess. I did not know that. And you get 0. So 12 times 228. Now we use that exact same long division. The important part is this part. So let's now do it with this. And I hope you go, whoa, that is so cool, because I think it's pretty cool. So here, I know that if it was 12 out the front, and I put in here x cubed plus 2x squared minus 5x minus 6. So I want to know that times what gives me that. So I'm looking for the quotient. And it should go in exactly, because putting that in was 0. Now I do the same thing. We always concentrate just on the x. I say x times what will give me x cubed. And that is x squared times x, but that's all of that. So when we do this, just expanding your brackets, I get x cubed plus x squared. Now that's the same as doing like my 12 times 3, or 2 wasn't it, my example, was 24. This is the 2, so that goes over the top of that, and this, the answer, goes underneath. So x cubed plus x squared. And I minus them. Now the other trick with this one, very, very, very important. It eliminates errors. You're minusing that and that, because you're minusing all of it. That should cancel out. And I've got a 2x squared minus an x squared is just an x squared, like I did before when I did long division. But now you bring all these down. I've got minus 5x minus 6. Now again, we just do x times what gives me x squared? Well, that is x times x plus 1, because that's out the front. It's like my 12 times whatever it was, gives me x squared plus x. So I wrote that down. I go plus x, and I go x squared plus x, and draw a line. And now if there was no x there, and you just put a 0 there, which we'll have a look at a bit later, again it's minus, minus. Put those in, makes a big difference. That should cancel out. I've got a minus 5 minus a plus x, so it's just a minus x, minus 6x minus 6. Now you should get something that you can times that by and it will go away, which it will. X times what gives you minus 6x, and that's minus 6 times x plus 1 is equal to minus 6x minus 6, and look at that. Up the top I get minus 6, and then I get minus 6x minus 6. And if you do minus, minus, that cancels out into 0. So that doesn't look too hard, does it? I think it looks pretty good. The thing is, practice, practice, practice. You can make a little mistake. Remembering, if you do make a little error, you show all you're working out. The error will follow on, and you'll still get your marks because it's a follow-on error. So now, let's go to here. I've now got that x plus 1, x squared plus x minus 6 equals 0. Now I still can't do my null factor theory here because I need to factorize this. And I've got lots of easy ways to do them. Have a look at that. I'll just take a picture of that so I can remind myself. And I'm going to show you my easy way of factorizing a monic. So let's go back now. We're going to just rub that out. You can pause and and I would suggest you write it all down and then practice it. Now we come to this, which is very nice, and I hope you understood that. It's x plus 1, x squared plus x minus 6. So now we know that that equals 0, and I always write on this side the null factor theory, whatever it's called, I always forget. And that equals 0. But I still need to factorise this now. So I've got a little rule. I like teaching it, many ways of doing it. But I'm going to teach you my rule because I like it. My rule is you always start with this one. If the sign is different, and I write this every single time, you find, if the sign is different, there's, the signs are different. So it's minus, the signs are different. You've got 1, you've got an x here and an x here. You've got one that's a plus and one that's a minus. And we find the difference. So I always write that up the top. Minus here, the signs are different and we find the difference. That's for the negative. One's a plus and one's a minus. The plus here, only for this, when it's minus, is the larger factor is positive. If it was a negative here, the larger factor would be negative. And then we do what we normally do, which is we look at this and we go the factors of 6 that the difference is 1. And we don't worry about the sign, is just 1, because we worry about the sign when we go to here. I always go, now if you don't know your factors, you go 6, it's the factor rainbows 1 and 6, 2 and 3. So 1 times 6 equals 6, and then 6 plus 1 equals 7. Not that one. Oh, it's the difference. 6 minus 1 equals 5. Not that one. We've got 3 times 2 equals 6, and 3 take 2 equals 1. The larger factor is 3, so it goes here, and the smaller factor is 2. And you can check it by doing x times minus 2 is minus 2x, x times plus 3 is plus 3x, which equals x, which is there. That's if you want to, but if you use this, the factors of 6 that the difference is 1, the factors are 3 and 2, the 3 is the larger factor, it goes here. If it was minus 1, it'd be minus 3. So when we get to there, we then go bracket, 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 bracket. So now I've got x plus 1, x plus 3, x minus 2 equals 0. And then we use the null factor theory, which says, I like to write it on the side, that if that equals 0, 0 times, no matter what these are, will be 0. Likewise, if that equals 0, 0 times whatever they are will be 0. And if that equals 0, 0 times whatever else is there is 0. And I like to write x plus 1 equals 0, or x plus 3 equals 0, or x take 2 equals 0. So you just move those across and you get x is equal to minus 1, which we found at the top, x is equal to minus 3, and x is equal to 2. They're your solutions. Good idea is to put it into Desmos or your graphics calculator. Practice using your graphics calculator, which will have a little bit of work, extra sessions on those as well. And if you put it in, you'll see the graph. X is equal to 1 and 3 and minus 2 is going to be looking like, and you should check where it's coming from, so we know it's there, there, and there, and it might look something like that. Who knows? But have a look in Desmos and your graphics calculator. There's your solutions. Use your long division. I'll do a few more of those just to show you some harder ones. But just remember, it's easy if you know what you're doing. Good luck with it, and if you get questions, just either send me a message or comment on my video. Thank you.